like to give a quick brief overview about myself and talk about a small deck that I've put together for the benefit of the group, and followed by a quick demo across the different frameworks. So as I mentioned in my bio, I've been with GE for quite a long time. Started in 2006, worked for different businesses of GE across different P&Ls, precisely in the opportunity of testing and test automation. Since 2006 until now, and still continuously going on, seeing the way test automation has evolved over a period of time. So I want to talk about how test automation has transformed and what are the best practices, and also would touch upon different frameworks that we have, and look at what is the full stack architecture from the test automation should or must look like, and the different capabilities and the ROI that you get out of if you follow certain standards and principles. And then moving into how test automation is transforming in terms of the design, with not just, we'll look at how the traditional automation looks like, and how with the AI and some of the newer features that are happening right now in the industry, and also look at some of the analytics that the test automation should project. So without further delay, so on the transformation, so I'll first give a quick insight into how technology, how the applications have transformed over a period of time. If you see, by and large, in the beginning, when I started my career in 2006, we had this legacy applications, be it mainframe, SAP, Oracle, ERP, and any kind of desktop applications or any kind of scripting-based applications. And then eventually web became the big thing, and every application that had legacy, they all evolved into web. And then from web, every application wanted to be faster, and every organization or every domain from across, they wanted to build some microservices and micro applications. And then now we talk all about is native, where it can be mobile or it can be device friendly. So this is how we've seen that the technology has evolved, and we will look at in line to those to the transformation of technology, how did test automation try to fit itself. So when we had legacy applications back in those days, when we had, for example, in my experience with GE, within transportation and aviation, we had several Oracle ERP applications, and much on the buy to pay and order to cash and different end-to-end scenarios. Accelerators, test automation using some accelerators. So we had accelerators back in those days, some turnkey accelerators, which would have some vanilla implementation that is already automated. And then the key parameters and attributes that support the accelerators are typically at UI projects. The data validation can also be done through the UI. It is heavily object repository dependent, and most of the times it is either VB or Java or any scripting languages. And OOPS concepts was typically low. So long story short, we had automation back in those days, and automation was like a buzzword. Everybody wants to automate anything that is done manually, and a lot of consulting organizations and a lot of organizations which are bigger in terms of the size, in terms of their application, in terms of their cost, wanted to have automation. So accelerators was a big thing. And then suddenly things wanted to be fast and fast, right? And when when everything is becoming more digital and everything is going to be on the web, so open source. So how the test automation evolved with the open source. So as we all know, the popular thing is Selenium, and there are several other tools using the different types of frameworks again. So I'll talk about the frameworks very shortly. But so open source, everything, either Java or you call it NUnit or C#, name it, but most precisely on the OOPS concepts. Etl Framework, typically to test the data between different hops from the time the files are loaded and staged, and any kind of business rules mapping on the data side. So any schema level validation and all that stuff. And that also includes some kind of localization, because most of the applications are supported across more than 20 or 20 different languages. And so typically you wanted to make sure that the test automation has evolved over a bit of time, and open source became a big thing, and everything was web. So there are different drivers within Selenium that supports for each type of browser that the application is compatible. And then once that is done, if you see test automation, right? So APIs, microservices, the RESTful services, GraphQL, Node.js, name the technology. Now, test automation as a platform, that's what I always say. The reason behind is that most of the test automation that you wanted to do at an API level, both the functional and the performance, and the data-driven testing becomes, or you call it for the UI, you're calling more at the acceptance test-driven development. But I can come back how it was done even on at the time when we were testing the legacy applications and right now. So test automation as a platform, right? So you wanted to do heavy data-driven testing. The TDM approach, which we call it as, which I call it as is test data management approach, wherein you're trying to insert data against, typically we have CRUD, create, read, update, delete. So you wanted to insert the data of positive, negative scenarios, especially the negative test data, insert the data through the API into the data source or MDM or any kind of view, and then make sure that the different controllers, the methods within the different controllers, whether it is a GET request or a POST request or a PUT, is you're trying to run your scenarios against the negative test data. And then once you read the data, you update the data, and then as soon as all the scenarios that are corresponding to those particular all the data samples that corresponds to those scenarios are tested, then you delete the data. So that's the TDM approach. So this is, I'm emphasizing more on that because over a period of my experience, what I've seen is that if most of the business logic is always in your API, and if you can extensively make sure that your APIs are thoroughly tested, and if the API framework is following the similar approach that the dev team is following, then you have a high ROI, and your capabilities and your defect leakage into the production is much minimal. And going into the test automation as you try to relate between the legacy web and micro-native, this is how the technology has evolved, right? This is how the applications have evolved. And the test automation from accelerators to open source to API to now we're talking AI. And AI precisely, most of the things that you see, the AI engine that is being built, it uses any kind of native language, like JavaScript, or it could be Java, or it is built upon Selenium. But more so that I'll also show in the demo with one of the tools that I was doing a proof of concept, but the smart locators, right? How the smart locators play a bigger role. People are saying that no code, less code, and it has adaptive language processing irrespective of what language you are scripting. And in terms of making sure that the synchronization and everything, so you write some ML algorithms to make sure that the element selection becomes based on the different groupings that you can do. The element selection becomes much easier, So those tests are not flaky, because a lot of times the UI tests are flaky. If you look at the testing pyramid, right, you have unit tests, then you have API tests, your integration tests, and then you have your acceptance tests. So as the pyramid grows, the acceptance test, what we say is supposed to be small in number, but your integration tests are the major chunk, and then your unit tests should have good coverage, so that as you're growing across the different from layer to layer to the presentation layer, right, your dollar value keeps increasing. So we will see how AI is changing the test automation. How is it really helping, and where do you want to do the AI? Right? You want to do the AI at the time of design, or you want to have the AI at the post execution? So we'll see in shift left and shift right what are the differences and how we can push that. Now, as I was saying, right, back in the days when we had HP QTP, which is UFT now, as it evolved. So we had this concept called as BPT, business process testing. So it is nothing but the BDD that we talk right now, the behavior-driven development. So anything and everything has a component, which is a decomposed component, and behind the component you have keyword-driven scripting. So whether we call an SME, or whether we call a functional expert, or whether you call a techno-functional expert. So our business guy, whatever names or terminologies that the companies might use. By and large, BPT was it was there in 2006. It's a similar BPT, the similar version of BPT, aka is nothing but your behavior-driven development, wherein you write in Gherkin, your manual scripts are in Gherkin, and you have bindings around those Gherkins, which are your feature files. And then for those feature files, you have keywords where you have your code. So people always believe that BDD is easy. BDD is anybody can do, which is correct. But again, to make sure that your automation scripts work well, so you need to have some strong or technical skills, be it any language, whether it is a .NET, C# or Java. So BDD is no easy. At the same time, BDD is very helpful because people love it for the fact that the manual Gherkin languages, the given when then will have the automation code behind those given then when is definitely you need strong technical skills who can understand the OOPS concepts. So without further delay, right? So I'll try to pause a bit, but again, what is that you're going to get as you try to progress? You want to the business impact, you want to have high business impact with the approach and with the frameworks that you want to deliver. At the same time, you don't want to make sure that you're not losing on the scope and the coverage. You want to enhance the scope and coverage with automation. Now, how do you do that, right? So one has to define an approach. So with my experience so far, being in the test automation for more than 15, 16 years, the approach that I strongly believe is one can follow a traditional approach where you can try to automate everything. But I believe in this. I've seen that the experience, the most important thing that pays is risk-based approach. When I say risk-based approach, right, when you have 10 different functionalities or 10 different features, whatever you want to call, if instead of automating everything in those features, you need to identify what are those critical, the 20/80 rule. So 20% of the within each feature or a functionality, what is the 20% which is more critical, and within that 20%, what are the different functionalities that we can cover through the APIs, if there are any services that support those APIs. So a lot of test automation should happen at the API layer, because most of the data, positive, negative, boundary level, any kind of validations that you can have can be done at the API layer, whereas a UI should have a limited set of functionalities like an end user flow, like a behavior driven, and those UI components should be integrated into the pipeline. At the same time, you want to scale the tests in parallel, whether you do it in headless or whether you do it in a compatibility tool. We will look at one of the compatibility tools that we use in GE, but again, so if you can scale the tests in parallel, at the same time, if you can also make sure that you only focus the 20% of the risk-based test cases in terms of the UI that you want to automate, and way more and depend more on the API automation, that gives the outcome as speed, right? So end of the day, speed is the key. So how do you define speed is the key is you can have a skill resource or you can have a smart tool wherein everybody can contribute towards automation. So that's the transformation slide. Any questions? It could be something that we all might know, but if not, I'll push forward. All right. So we'll look at the full stack architecture here. I'm going to show some of the front end. Um, we have Java projects, we have Site for applications, we have .NET, and we have React Native, and in the backend we use all these different tools that support us, whether it is microservices, RESTful, or GraphQL. And test automation is all about building. It's kind of, according to me, the way I look at it is it's building a Lego block. So unlike any other testing, whether it is security testing or whether it is a performance testing, things are slightly different, but with test automation, right? So I kind of put, these are the different tools and these are the different languages. And there could be some questions like, why do you use Java, just TestNG, why do you have Spring Boot and NUnit? So typically, testing should always align with the development methodology. So whatever the engineering team is following in terms of the framework, if the engineering team is building the framework in a .NET Core, Site Core, and Node.js, so you have to look at, you need to make sure that the test automation code is sitting right into the same code base of the development code is. And by the advantages that with that approach is, one is CI/CD will be seamless. Two is the feature branching is the feature-based test automation is rightly possible. Number three is that there is high traceability in terms of what's getting automated and what's being delivered as part of that particular release or within that particular sprint. So if you see by and large, we have different IDEs, so each of them support web-based applications that are with Java, web-based applications that are Spring Boot, .NET applications, and then mobile native applications. And then now the framework is typically, whether you follow a test-driven framework, whether you follow a BDD framework, whether you follow a Java TestNG, whether you follow a .NET NUnit framework, or whether you follow Spring Boot or microservices, any kind of framework that you follow, the development workflow where I'm pointing, having some exceptions and the utility libraries and the dependencies, respective dependencies, and object repository, we'll focus more on the object repository in our demo as well, and test data and the reporting. So all of this becomes, these are the basic attributes that make up the framework, right? And the approach is typically most of the test automation frameworks, the approach is to follow the page object model. There's a pros and cons with that. And the advantage is when you have page object model, everything in that for that particular page, if it is a login page, all the necessary objects and all the necessary classes and all the necessary custom or common libraries can be managed for that particular page individually. The reason behind is that most of the test automation for the web-based applications, the open source, whether you're using Selenium or BDD SpecFlow or Cucumber for that matter, or any other tool or technology, right? Or the basic thing is that everything is going against the DOM object. And there are different types of DOM object. There could be structural, there could be linear, there could be, there are some index properties, but by and large, we have to, the test automation is heavily dependent on the DOM objects. And one of the reasons how, that's the traditional way of test automation. And we will also see how AI is changing that and how AI is trying to make sure that test automation is much faster. Whenever there's a change, how can that change be, how can the change management, right? Especially when the developer makes a change to a particular locator, or whenever the developer adds a particular locator, or whenever the developer removes a locator, the test can break. We'll see how the AI handles those scenarios. So, long story short, there are different types of AI tools. You have app plans. These are all commercial tools again. But the full stack architecture, the reason why I wanted to emphasize on this is while you build the framework, you needed some execution platform. So some people use Selenium Grid, Device Farm, CVD of SmartBear, or it could be anything. So, but net, we will see in our particular today's demo when I'll be talking about how API automation is done using Ready API, and we'll see the cross-browser testing, the parallel testing that I was talking across different browsers in CVT, and also for the device compatibility if you want to run it in a cloud environment, so that you free up your local IDEs so that you can use for the active development. We will see AWS Device Farm, and we'll also see one of the couple of AI-driven interfaces using Testim and Report Portal, wherein you will see the different type of metrics, how we capture the metrics. And long story short, right, as I was talking, the shift left and shift right, which I'll mention, the test automation is not complete if it is not CI/CD, number one, which is what I believe in. And again, every test engineer, that's a fundamental quality that we need to make sure that when you build our test automation, it cannot sit in a local box. It has to be integrated into a pipeline. So the test automation should reside in a common tool GitHub. At the same time, one should also have some monitoring for the production environments. So there are different tools that you can use, New Relic, and then once there are some issues, it has to be integrated into some kind of a workflow system. So this is the full stack architecture, and as we see different roles in testing, right, tested, whatever you call software development engineer in test or whatever it is, but one should be able to drive from manual to API automation to UI, and one should also make sure that what should be functionally automated, what should be part of regression, what should we really automate. So that's what it matters, right? So anything that is very critical to the functionality, the code which is very vulnerable. So the test automation, once the execution is done, there should be some kind of analytics that should feed as a feedback, and the test should be smaller and the decomposed state so that the tests are faster and it gives more feedback early in the phase. And so that's all about the full stack architecture. But any questions on this before I move to the capabilities and ROI? I am audible, right?
Yeah, you're audible. I had one question. Just is Ready? I may have missed this, but is Ready API just like Postman, where you make API calls?
So Postman is Ready API is a SmartBear product. So they've come up with to answer to your question, right? Postman is part of the SmartBear. Postman is more, you cannot orchestrate automated tests in Postman typically, but with Ready API, right? The same API test can be used for your functional testing, which is, they have different components in Ready API. They have SOAP UI, Load UI, Service Pro, which is for service virtualization, and security testing. So there are 4 different components within Ready API. So you need to have different licensing. It's a commercial tool. So for any functional automation, you do the SOAP UI Pro, and then you can, with the click of a button, you can convert them into Load UI tests, and you can configure load on the same on the APIs, and you can run your load UI test. And for example, if the development team is yet not done with the APIs, then you can have virtualized services and then like a mock service, and you can insert the data against that mock data factory, create a mock data factory, insert the data, and run your test before the API team is done with the development. Did I answer?
Yeah, no, totally get it. So it's just more of an encompassing and broader tool than just Postman.
Yeah.
Gotcha.
Yeah. And token authentication, everything can be done as an event. It's a pretty powerful tool. We before Ready API had REST assured framework, but not everybody could upskill to the REST assured framework in no time. But with Ready API, more than 70% of our manual resources are now automated, and it's black box. But again, if you want to do any kind of scripting, you can do Groovy scripting, connect to the database and inserting the data into the database. So we use Ready API across our cyber portfolio, within our CDX, across everywhere.
Okay, gotcha. Thanks for all that information.
Yep. Going to the capabilities in ROI, right? So shift left and shift right. So typically in sprint automation, acceptance is driven. These are all qualities and attributes. Most of us are aware of that, pair programming and everything. The most important thing that comes into the picture of shift right is how do you make sure that your production environment is also well taken care of. So you need to have some synthetic monitoring in place using different tools, whether you App Dynamics or New Relic or any other tools that are there in the marketplace. But for within GE, we use New Relic heavily. And synthetic scripts, you can have synthetic browser scripts, or you can have synthetic API scripts to make sure that your platform is working fine from the API standpoint. And from the UI standpoint, you also want to make sure it uses Selenium again in the backend, and it is all headless. It uses Chrome as a browser. You can configure it in different locations. I'll show some of the scripts, but again, it's a beautiful tool. So shift left and shift right has to happen in parallel, and that's how one should. Those are the strong capabilities, and the ROI typically you get is savings over time, right? So you get, before your customer tells you, if you have a monitor that is monitoring a synthetic script that is monitoring your application every 15 minutes or every 10 minutes, and it gives you information, hey, something is done. And that's the ROI that you get. And before your customer lets you know, you can make that impact ahead of the time. With automation, right? As I said, you don't want to automate everything and anything. You want to automate that is critical to the functionality. So that, and you also want to make sure that there's some. It is again, the discussion is at large. Is like, some of the times, whichever is manual, people will dump on, say that I want it to be automated. But again, is it done every time? If it is, yes. Otherwise, you want to make sure that you want to park it outside if it is not critical to the functionality. Wherever there are, as I said, the redundant tests, and most important thing, right? The way we advocate within GE is test automation is no different than development, active development. And a test automation engineer should have skill with Java, .NET C#, Groovy scripting, any kind of language that the development team uses. So the test cases, the manual test cases, are just to make sure that it gives a t-shirt sizing estimate or a detail estimate and effort. But again, the reusable component, reusability of the code is prime. And how you do it is constant refactoring of the code, making sure that you're enhancing the code as much as possible. Every test automation team should have a tech debt. And I strongly believe in that. The reason behind is that the application is changing. It is very dynamic in nature. One should look at a functionality and a feature, like development, active engineering team will look at it, and then start developing. If there is a filter, so the filter is used in different screens. The filter properties of the locators could be different in each screen. It depends upon from project to project. So managing those object repositories in an individual class file instead of in a property file is helpful, because the compile time, the performance is much faster if it is in the same, if it is managed as a separate class file. I'll also walk you through in the demo how it is done. Traceability. So once a test automation is done, it should feed the results back into any kind of agile tool where the test cases are managed. It could be version 1, Rally, or any other tool. And the most important thing is running the tests in parallel instead of linear. So those are the things that will, the project, the organization will have more savings over a period of time. So these are certain capabilities in ROI. Now let's look at, if there are any questions, please let me know. But intelligent test design, what I was trying to talk in terms of how the traditional test automation is done. If you see in the traditional test design, it's more single DOM object, heavily dependent on the different locators. The data processing happens linear. So if there is a failure, The visuals are more reactive. You look at an error and then you figure it out. Okay, this is the issue. You don't have AI or ML with the AI in place, right? So the tests are more self-healing. And when it's a self-healing test, the tests are learning as they are getting executed. Basically, you will have comparative visuals. So you'll have baseline screenshot, and then the screenshot that, for example, a particular button is gone. And on the fly, you can make changes to the, during the execution dynamically, you can make the changes real time and make sure the script passes. You have smart locators. When I say smart locators, right? Instead of, for example, if there is a button that says click, in a traditional test automation, the click will have a particular, either it is a text property, or it is an XPath, or it is an index, or it could be anything that the developer is, the test automation engineer is using. Whereas in AI, you'll have more grouping of the object properties, and that when the test is executing, it is trying to check for each of the object properties. And if any of the property is found, the test will pass instead of failing. And adaptive processing. So most of the times in our Selenium or in any BDD, why the tests are flaky is because of the reason is that synchronization. Sometimes the application is faster, sometimes the application is slower, sometimes the application is hanging. So the test does not self-fail, the test does not learn, and it will fail. Whereas with AI, it is not like that. So there is a, you can have an adaptive wait time wherein the during the runtime and the real time, the test is learning. And the reinforced AI ML is going to help the test to be more stable than being flaky. Any questions before I move forward? All right. Yeah. Did I hear anything?
Oh, no, I was just going to say no questions so far from me.
Okay, cool. Coming to the test automation analytics, right? As end of the day, everything is done. The testing, the automation scripts are run, they ran fine, and you have execution results. You're looking at different analytics. So the typical reporter that is used is Extent reporter in most of the frameworks, and they're beautiful reports compared to the previous reports we had, like ATU reporter, or there were different other plugins that we used to use. But Extent reporter, it gives you a GUI format like this, a dashboard, in which device, if it is a mobile that is being run, and when was it run, what's the start and end time, and all the necessary based on the way your script, based on the different methods within the Extent Reporter Manager class you have used, you can have that such HTML report. Now, the biggest catch with this is, even though it gets generated a report, you have to manually analyze. And most of the reports are static. It doesn't tell you, the report doesn't give you any kind of classification, whether it is a product bug, whether it is a system issue, whether it's an application issue, or whether it is a code issue. And you don't have any AI or ML. But whereas within AI integrated tool that we are going to see in the demo that we use, you can have an auto analysis feature wherein it analyzes what the issue is. And at the time of execution, right, typically in a traditional model, right, if you're running the scripts, and until the results are, until the execution is complete, you don't really get a feedback whether the tests are running fine, or that they're going to be passed or failed. You can definitely look at the console, which is a live commentary that will tell you. But again, you wanted to make sure that when you have, as I was talking, like an SDET, where you're running your API tests, where you're running your web-based tests, and where you're running your mobile related tests. If you're orchestrating those tests together, you wanted to see real-time analytics, and you wanted to get you wanted to classify those issues faster, whether it is a product, system, application, or a code issue, and then create a defect. You need to have the integration with either Jira or Bugzilla or any other tools should be seamless, and you needed a visual dashboard. And not only that, right, you can have some AI ML configuration on your results, on your historical data that tells you that, hey, within this particular login feature, this particular functionality is always failing, so it is vulnerable. And then that failure prediction will allow you to make sure that, okay, this needs to be executed every time as part of the regression whenever I'm running. So we will see one of the tools that we will integrate, but we have integrated that gives you those analytics. Any questions before I move forward? Cool. So before I get into the demo and give and walk through guys some of the code, basically is that you have to build automation that really matters and that works. So that's the messaging. So without further delay, I will let me know if you guys are seeing my screen.
Yeah, we can see your screen.
Yeah. So I wanted to show, I've got several projects that I've configured within my local machine. And so this is a web-based project for one of our application within our CDX. And the typical folder structure, as I was mentioning, would have is like within your source folder, the different action pages and the driver script through which your script execution happens, and the different utility libraries. So this is for a standard Java test NG. Similarly, if I have to show, even for a Spring Boot project, which we have. So this is again a mobile project where we have where I was mentioning, I wanted to show you guys the object repository, right? So if you see for each of the pages that we have, so we have login, home, equipment, service. So these are the different features within our mobile application. And for each of these different pages, I've got the object properties clearly, nicely maintained in a separate class file. And most of these are managed as different property files. And each of this is for an Android project, but we are slowly migrating. You want to make sure that you maintain single code base, and for that, you have to depend on context value or accessibility ID for the mobile application. But long story short, what I wanted to show you is that the folder structure for the object repositories and the driver script. So you should have, if you see whatever classes that you have for your action pages, you will have several driver scripts. Apart from that, you will have certain demo projects, class files that I will be running today. This is the project folder structure. And at the same time, for each of those respective class files, you maintain test data separately. And you maintain the test data in different data providers, along with the different test case IDs, so that whenever you're running the test, it is much evident in terms of the traceability. And for example, if I go into a particular action page, for example, if I go to the login page, and you'll see that all the different object properties that we are calling for property files are managed at the beginning of the script. And then typically, these are the different action pages, but most of the test cases are managed here in the driver script, wherein you kind of establish traceability, providing the test case ID. So we use Rally as the single snapshot for the test case management. So this is on the folder structure, the way it is managed. And as I was mentioning, that the object repositories, for example, if you look at login page, so for clicking on sign in, we use this property, text property, right? And in order to click on any button, you use again text property. So you're dependent on single objects. So this is the single document object model. That's the traditional way of looking at it. We will see how in AI it looks like. Okay. So this is a Java project again, and you can set up parallel execution. We will also see how you can do the parallel execution. Same thing with for the web projects. We use CBT, the cross-browser testing tool, and the CBT gives you to manually run your tests on different browsers with different versions. And same thing in automation, we have 15 parallel sessions that you can run in parallel. And I'll run some smoke tests and we'll see how it looks like. And at the same time, this is on the UI piece. Now, as I was mentioning, 1 second, how do I minimize this one? Sorry. All right. Yeah. So this is all right. So this is an AI tool. It's a third-party commercial tool, testing. So if you see, the way I was mentioning is that on a particular screen, you can have different locators. So what the tool does is that it technically selects each and every type of object, whether it is an ID property, index, text, class, tag, any kind of structure or any kind of object properties. So what happens is that when a change happens, for example, in this particular screen for products, so if, for example, somebody has updated the product screen and the object property for product, the text property is updated. And in the traditional automation, right, as I was mentioning, if you see in the traditional automation, you'll have single object repositories, a single DOM object, single locator as text. And if the text, for example, the developer made a change to this text and they said login with employee, and they removed SSID, the test will fail in the traditional. Whereas in your AI, it will try to group because it has different objects that has been selected. And it will, if the text property fails, then it will look at the href, or it will look at the tag, or it will look at the index property. And based on that grouping, the test will not fail. The test will be more stable. So this is something, I think they have something called as reinforced AIRML. Now, these tools are not open source. They are commercial. I don't recall if there is any open source solution for this, but this is again only UI. It doesn't accommodate and support API at this moment. So it's again up to you. Most of the startup companies, most of the companies wherein you have the developer and tester as saying the same person who is doing it, these tools are much powerful because you can either record the text, record the workflow, and then if you wanted to adapt the test with more validations, then you can convert into a scripting using JavaScript. And they are seamless into CI/CD. The integrations are pretty powerful. There are several tools in the market, but Testim is definitely one of the powerful tools that I can say. So that's the difference in terms of the development between the traditional automation and the AI. Now, I'll try and run some tests and we'll see the parallel execution that happens with CDT. Now, the same thing in terms of the reports, right? So as I was mentioning, let me pull up a source report. Yeah, so the extent report that I wanted to show you guys. Yeah. So this is a simple report. It also has a dashboard. It will tell you what the test case is, whether it is passed or failed. If there are any further steps, it will give you all the different steps, and it will tell you in which environment or which device it was run, and what is the device version, what is the device name, and which region it was run, when did it start and when did it end, how much time did it do. So it will give you all these details. But this you need to wait till the test gets completed before you can generate this report. Now, we will look at a AI-based test automation analytics report. Give me 1 second. This is again an open source thing. So this particular report, right? So you can integrate whether your API test, your Selenium test, your mobile tests, everything into this tool. And this tool will, as the tests are getting executed, you will see the real-time execution that is getting updated. And you can, for example, here I have an issue. So if I have to, on the fly, if I have to see what the issue is about, okay, this is a bad request. So I can go click on investigate, and I can say that, okay, this is a system issue. for example, and you save with necessary description. You come back to the results, and you will have a system issue that is created. Give me 1 second. Do not. Okay. So what the advantage with this type of analytics, it updates the system issue, and you can create a defect, and it gets, if you have integration with Jira or Bugzilla, on the fly you can create it. The advantage with it is you can also generate some custom dashboard, and in this dashboard, it's an auto-populated dashboard, and you'll have different widgets in terms of like what are the test cases in terms of failure across the API and UI, and how many product defects are there, how many are automation bugs, and how many are system issues, and the different launches. So this is at a leadership level and at a management level to look into the different projects that they have. So we have 13 different projects across the different verticals and different components of CDX, and we have test automation that goes across the board. And as a test automation leader, I myself wanted to see how is each team, when is each team running, and how many tests are being done, and what is the ROI in terms of the efficiency. How can you measure the efficiency for test automation? Right? There are two ways that I look at, that I see in my experiences. One is the defects that are found through the test automation fast enough. And when the defects are found, you need to analyze faster from the results. And you need a tool that can help you to say that, okay, this is a product defect, this is an automation defect, this is a system issue. So that investigation should happen pretty fast. That is how you can measure an efficiency of test automation. Number two is the ROI that you get in terms of any kind of redundant tests that are there. If those tests can be automated, and the amount of time that it is saved by automation, that is number one thing. So how do you measure the efficiency? Is that a tool like this will tell you how many tests are run and how much of manual effort is saved to run a regression for a particular project. If it takes manually 3 to 4 days, and with automation, if it can be done in 3 to 4 hours, and if you can have them scaled in a CPD tool like this, wherein you can parallelly run the test. So nothing like it. So any questions before I can go ahead and start running the, you go ahead and start. If you have any questions, please let me know. Otherwise, I want to cover one last thing, is the New Relic tool, which is a monitoring tool. So you can have synthetic scripts, for example, as I'm going through this. So these are some of the synthetic scripts that we have, and most of the scripts are configured. You can configure it in different locations. And for example, let me show you, you have different public locations. You can create your own minion, and you can run it on a private minion, whether it is in an AWS or in any kind of Azure blob you have, and you can enable this. And once they are run, you will have different results. So as this one is running every 15 minutes, and I can go back and take a look at if there are any failures. I can filter by failures, and I can look at the different screenshots, what the screenshot looks like, and you can have custom data that you can print onto the console. So typically, this is nothing but shift right. So before I can start running the scripts, any questions from anyone? Am I being fast, or am I making sense? I'm sorry.
I think you're going at a good pace. It's just a lot of information. So I might have to actually re-listen to this later.
So let me run. So I have an Android emulator device, mobile device. So I want to show you guys. 1 second. So this is I'll run this as a test ng suite. And parallelly, I'll also run an API test. I think I haven't tested upon with you guys on the APIs, but what is running? 1 second. Once it gets kicked off. Yeah. Let me see. While this is running, let me open the Ready API. So as I was talking, right, the Ready API tool. So this is the tool, Ready API, the way the interface looks like. So you have SOAP-UI, and these guys have got a decent dashboard as well. But this is for one of our projects that we manage in mobile. So you can have different controllers, and each of the controllers, I'll go through some of the TDM approach that I was mentioning. So let me.
So I got a question, actually.
Sure.
I saw that you're pulling up the emulator for your mobile application.
Mm-hmm.
Do you also cover automated testing with different OSs and different versions of different phones?
Yeah, we do. So one is that we use AWS Device Farm. AWS Device Farm, where you can where you have different pool of devices, and you can run your tests either on an iPhone, or you can run your tests on an Android device. Different Samsung, different versions. Yes. To answer your question, yes.
Okay. Cool.
Yeah. And for browsers, we use cross-browser testing. AWS Device Farm also gives you to run your tests on different browsers as well, but CBT has been much powerful. CBT, the smartware, has a different product called Bitbar. It's more of like AWS. The reason why we chose AWS Device Farm is because we have a titanium partnership with AWS, Amazon. At the same time, AWS Device Farm, you can actually, when you build a project, so the target file, the zip to target file, whatever target file that is created, you don't need to, for example, right now, my Eclipse is occupied because the tests are currently running in a mobile. Whereas you can package the zip file, the target file, you can zip it up, you can zip it, and you can actually, when you create a test run, right? So I'll show you how we have a Jenkins job wherein I've configured this in my local for now, but again, the Jenkins job, it will make a connection with, let me kick it off and see, I'll show you. So the Jenkins will, give me 1 second. Yeah, so let me talk through. So it connects to my GitHub project, and it will download the necessary dependencies. And once it downloads the necessary dependencies, it will make a handshake with AWS Device Farm. And in Device Farm, based on the configuration that I have selected, it will go ahead and launch that particular device, and it will run. Right now, I have a .apk build that is configured, but it will run that particular. It will launch the app, and it will run the necessary functional scenarios. And with the Ready API, right? So this is the TDM approach that I was talking about. You can insert the data and into the different data stores, whether it is PostgreSDB or whether it is a ES2 data source, or whether it is any kind of database. Based on the necessary jar files and the handshake that you have, you can go ahead and insert the data, and you can review the data, and then you can loop through the data. And again, once the tests are done, you can delete the data. So that's the TDM approach that we follow across the board. And let's see here in the report portal. So let me go to the launches. And here, if you see, I'm running the RPM script. So it is feeding, it is giving me the real time, saying that, hey, there's a test that is going on. And now I'll run for the web project. This is the Maven project. So let me run this one, and I'll show you guys. Yeah. Yes. As this one is getting kicked off. Yep. So it is now starting. So this is integrated into CBT, and it also feeds the information into our analytics tool, our AI tool. So we will also look into, we'll also see, I'll go through that AI tool for the reporting and how it is so beneficial and how it is helpful. So give me 1 second and see if it made a contact with it. Yes. If you see here, there is one session that it started. And if I go to this particular session, I'll be able to see there will be video recording of the test that you can go ahead and navigate through what happened. This is very helpful, and you can share. It's a public URL that you can share with anybody. So whoever does not have access to the CBT will be able to get through. Now let's come here and refresh and see if, yep, the Selenium test ng has started. Now I'll run the ready API, the API test as well. Let me run. Yeah. Preferred equipment. Yes. So this is running. I think this is pretty fast. So for all equipments, same thing. Yeah. And if you go back to the here, so here I'll be able to see there's a ready API test that is currently going on. So across multiple projects, from the management standpoint and from the leadership standpoint, if they wanted to see how are the different projects managed, to manage the execution, to manage the analysis of the automation results in real time. And as I was saying, right, so for example, this test is currently going on with the Appium, and I wanted to see how the tests are going on within, so the bat file has executed. So in the login, I wanted to see what is going on. So based on the different method types that you have provided, so the setup is done, and this is the test case that is currently running. And real time, you can see if there are any issues. And if there are any issues, you can create a defect. And if there are any attachments that are there, you can. So the traceability is much high with this tool. And this is this is an open source tool. And again, this dashboard also has a flexibility to configure any kind of AI. When I say AI, in terms of auto analysis of the results, any faster investigation and letting you know what are the vulnerabilities in the tool. So all that is possible with this tool. And it has seamless integration, as I've mentioned, and it has got a nicer dashboard that tells you. So these are some of the powerful with an end-to-end, right? So you're running your UI test, you're running your API test, and once it is done, it will tell you that the test is complete. So you're running your mobile tests in parallel, and you can see how your application is behaving. So, for example, we use GraphQL in some of our applications, and some of the GraphQLs are shared across your desktop and as well as mobile. And a change that is made to it can break any of the existing functionality across the board. And if you wanted to make sure that you rightly catch the defects early in the phase, so you have to have a digital framework that can run the GraphQL API, the UI, the API, the native app at the same time. And you should be able to look at the results in the real time instead of waiting for the team to tell, hey, there is an issue. So even in Jenkins, when you integrate, most of the times all that it happens is that you integrate the stuff into the Jenkins, but you will have to investigate the results, and you have to, based on the results, you have to make sure that you will be able to tell to the team, hey, this is an issue. Instead, if a portal like this is available across the board to everybody in the project, they will be able to see what's going on, and the Scrum team will be able to address the issues much faster. That's all I had planned to showcase today. I don't know if anyone has any questions. Or was the session informative? Any feedback would be helpful as well. But mostly the things that I've planned to demo is that the different frameworks, the tools, and the approach that one should follow. One should look at how the test automation should be done, and what kind of analytics and metrics that one should look at, and what kind of monitoring should be in place, so that it helps the entire different layers of software development lifecycle.
Yeah, that was very, very informative. Like this hour just flew by. It was definitely an introduction to a lot of new tools that even I have not yet used. I know some of them it is commercial and some of it is not, but I mean, I don't have any question. Does anyone? I know we've got people trailing off a little bit, but do we have any questions from the crowd?
Again, if someone has any offline questions, yeah, G, please let me know, and I'll be glad to learn and implement and share at the same time.
Yeah. I'm going to take this silence as a no. But if anyone does have questions, you can very easily find, I think the best place might be just to post on the comment section in this event, unless if Kalyan, you have another place where you'd like.
No, I think that will be great. Yeah.
Okay.
Comment section in the meetup, it will be helpful. I can take a look, and if someone has anything, I can go back.
Okay. I think people are starting to drop off a little more, so we can just end this here and divert them to the meetup page.
Sure. So I'll go and stop sharing.